Hi, this is Mr. Beck does your homework. This is AP Physics homework number 25 about rotational kinematics. And this first problem says a record has an angular speed of 22 revolutions per minute. What is its angular speed in radians per second? So this is going to wind up being a conversion problem. And so we're going to start off with 22 revolutions in 1 minute. So I could write that as 22 revolutions on the top and 1 minute on the bottom. Well, our first thing, let's just convert minutes to seconds because that's easy. And I know that on the top, 1 minute is going to be the same thing as 60 seconds on the bottom. That way, minutes is on the top, minutes is on the bottom, minutes could cancel out. Next, we have to turn revolutions into radians. And so what we know is that revolutions, since it's on the top, let's put that in the bottom and make that say revolutions. And I know that one revolution, once all the way around the circle, is going to be 2 pi radians. And so now revolutions is on the bottom, revolutions is on the top, revolutions will cancel out, and that'll leave me units of radians on the top and seconds on the bottom. So I'm going to get units of radians per second, which is what I'm looking for. Now I have math to do, and I have 22 divided by 60 times 2 times pi, and that will give me a value for how many radians per second. So that is going to give me the answer to question number 1. Now, question number 2 says, through what angle does it rotate in 1.77 seconds? Well, radians per second, that is my angular velocity. So that's going to be the omega. Now, I know that in linear terms, if we have a velocity, that's going to be the change in position divided by the change in time. So the how far the position has changed in a certain amount of elapsed time. The same thing happens with angular velocity, where it's going to be the change in angular position divided by the change in time. So in this case, I have the omega, I have the angular velocity of so many radians per second, and I'm looking for through what angle does it rotate? Well, that's going to be the theta. So I'm looking for the change in theta. I have the omega that I just solved for before in my radians per second. I'm looking for the change in omega, the change in angular position, and I do know that my elapsed time is going to be 1.77 seconds in my problem. And so therefore, we need to figure out using the equation, omega is change in theta divided by change in time. I'm solving for change in theta. And so that is simply going to be the angular velocity times the time. So we have the value for the angular velocity. We have our value for time. And when we multiply those two together, we will get how many radians, because it's radians per second times seconds will give us radians. And that will be how many radians this rotates through in 1.77 seconds.